Hey everyone, want to welcome you to the latest edition of Mathematics for the Impatient. I'm here with Stan Kladko, co-founder of SKALE. So Stan, I know that you were at Token 2049, which had a lot of cool and interesting conversations that went on. There's one in particular around shards and app-specific chains that I know you had on stage, as a matter of fact, with Emin, who's, I believe, the co-founder of Avalanche. So let's start with that, because I think a lot of people have this question, because I know Vitalik had brought up shards in the past and then moved off of shards. Can you explain for us really clearly, first, what a shard is, and then kind of secondly, what an app-specific chain like SKALE is?
Yeah, that's a great question, Marcus. And so shards, some call them networks. I think Avalanche calls shards networks. We at SKALE call our blockchains app-specific chains. And people are asking, what is the difference between shards and app-specific chains? And the difference actually comes to a mathematical term, which is coupling. So there are systems, large systems, which are weakly coupled, and there are large systems which are strongly coupled. To give you an example, let's talk about computers, how computers were in the 60s, right? In the 60s, people thought about computers, about these huge things like supercomputers, right? You would have a room, and in a room you would have shelves, and in those shelves you would have processors and wires, and all of the magnetic drives and everything, and you would have many shelves, and all of the things were like interconnected and blinking and doing some number crunching, right? That was the computer of 60s. But the point was that there were so many wires inside that, and then you would take scissors or whatever, and you would cut any single wire, and the entire thing would go down. So the supercomputer is something really tightly coupled, and tightly means, or strongly means, that if you cut a single wire, the entire thing goes down. On the other hand, the entire thing is very powerful exactly because there are so many interconnects, it actually forms one big thing. On the other hand, the internet of today is weakly coupled. You have your laptop, I have my laptop, there's a server somewhere, there's a wire, I stick the wire into my laptop, it becomes part of the network. I actually pull the wire out, it's out of the network, but it still works. On one hand, the interconnection is much weaker, so your laptop and my laptop can't really work together. They can't really share the computational power so well as supercomputers can. On the other hand, the weakly coupling actually provides this resiliency, so my thing can actually work independent of your thing. So basically, both shards and app-specific chains solve the same problem. We have the entire world now that wants to use blockchain. They can't just have one single blockchain, so we kind of want to have many blockchains, but in case of shards, all of those blockchains are really coupled. Think about all these wires in the supercomputer, and they all know about every single step they do. And in case of app-specific chains like SKALE, think about internet. There are blockchains, they're somewhat connected, they can send messages to each other, they can interact, but frankly, if your blockchain goes down, mine will still work. So this is the difference. App-specific chains are weakly coupled, shards, or some people call them networks, as in Avalanche, are strongly coupled.
Fantastic. Let's jump into a little bit of a deeper dive. I guess what would be really helpful for folks is to understand a little bit better, what are the advantages of app-specific chains versus shards, and vice versa? What would be the advantages of a shard over an app-specific chain?
Great question, Marcus. I will start with this kind of personal story. When I was a boy, I was reading lots of science fiction, and one science fiction novel that I read was written by a famous Polish science fiction writer. His name is Stanisław Lem. And this novel was about this planet where all of the human life was long gone. For whatever reason, humans destroyed themselves. So the only thing which actually remained was computers or robots, whatever, AI. And so there are two types of AI on this planet, and they were like fighting. There was a war. So one side was this huge supercomputers, essentially like cities, and the entire city was a supercomputer. And they were extremely powerful, doing huge number of number crunching, extreme amount of computational power. On the other hand, there were these tiny nanocomputers, like a nanobots. And each of those nanobots had like minuscule, a tiny amount of computational power. But what these guys could do, they could connect. So they could actually connect, self-organize, and actually share their computational power to create this swarm. And the swarm computing was able to do lots of things. So then when the war started, what happened was that when the small guys attacked the big guys, every time any single supercomputer was destroyed, it was a huge loss for the other side because a huge amount of computational power would go down. And then for nano swarms, what would happen, let's say you have a swarm of these nanobots, and let's say like 1/3 of them get destroyed. What happens is that the rest of them can actually reconnect and again form a swarm and again start working. So this infrastructure where you have weakly coupled things that can quickly reorganize, reconnect, turns out to be much more resilient. And as you imagine, they won the war. So that's really the difference between resiliency of app-specific chains and resiliency of shards. At SKALE, what we want to do, that was our purpose from the beginning, to take Web 2, the internet as we have it now, and move it to Web 3, essentially turn every website into a blockchain. So we do need to have millions of chains ultimately, just because on the internet we have millions and millions of websites, right? So we do need this huge number of blockchains, and for us it's really important that the system is resilient. So if we have 1 million blockchains, well, for sure some of them will go down. For sure, some of them will get hacked and crash. It's impossible for a complex system to guarantee that every single piece will stay forever. But we want the resiliency of the entire thing, meaning that any single chain going down or any single chain having a problem shouldn't actually kill the system. And that's actually what we already have on our network, where I think we count all of the chains. We have so many of them. We're now running on different SKALE networks. And we've seen situations where some of them crash, or some of them just slow down, or something bad happens to them. And the great thing, which in our case, is that the rest of them keep on working. So the entire system never goes down. It's a loss, but it's not a catastrophic loss. While if we would implement our system as 1 million shards with all of the wires, like all of the interconnected things, well, one of the chains will go down and the entire thing will die. And that's something that we cannot allow to happen. We want the system to continue working, even though some of the parts of the system may get temporarily disabled or crash. So that's app-specific chains. If you want 1 million chains, the weakly coupled architecture is much better. Now, if you want to have 64 chains, for instance, Ethereum ETH2 is planning to have, I think nowadays, 64 chains. The shard architecture may be still great, because if the number of blockchains is limited, they all couple together, they all watch each other, the security becomes great, because essentially you have 64 blockchains, all of these wires, all the connections, each of them watching each other thing. And then if each of them, any of them gets hacked, guess what? They can watch and fix the problem. So the strongly coupled architecture works if you want to scale in a limited way. If you want to go from 1 chain to 64, it works. If strongly coupled is great. If you want to go from 1 to 1 million, that's where it stops working. And if you think about, that's how the history of computing also went, right? Like people had just initially 1 computer or 2 computers, and up to a certain limit, scaling in a strongly coupled way works. People kept on creating these larger and larger supercomputers of strongly coupled processors, but at some point they actually reached the limit, where moving to a weakly coupled architecture started to make more sense. And now the supercomputers we have now are just connected small computers. Like, you think what people now, how people now build supercomputers, like the US government, some of the largest supercomputers that the US government now has are just many Linux machines connected to internet. Because at some point of complexity, it actually makes sense for you to have weakly coupled architecture. So to finalize, in our case, when we want to build Web3 weakly coupled systems, great, we won't have specific chains. For some other reasons, or for some other purposes like ETH2, where you just want to speed up the existing ETH1 chain, 64 shards also makes sense. So we are saying, ETH2 has shards. We hope that in the future, all of these things taken together will allow us to scale blockchain and more people to use blockchain around the world.
Fabulous. All right, so that was app-specific chains versus shards. Join us for our next episode. If you want to follow us on Discord or Telegram, just look below. Our Twitter is SKALE Network, and we will see you next time. Thanks, Dan.
Great. See you next time, guys.